Hi friends, welcome back to the second video of how to learn CAD introduction. Today I am going to take the angle of projection topic. So to understand the angle of projection topic, first we are all taught about the quadrants and the planes. So this is a 2D diagram of the quadrants and the planes, two perpendicular planes. So I have tried to make a 3D view of how this 2D diagram can look. So if we understand this 3D diagram, it will be very easy to point out the diagrams on the paper 2D plane, because we have to make 2D drawings always of the 3D objects. So for the angle of projection, there are four angle of projection. The first quadrant, as we know, this is the first quadrant. So the first quadrant is the first angle of projection. The second quadrant is the second angle of projection. The third quadrant is the third angle of projection, and the fourth quadrant counts for the fourth angle of projection. So to understand what is happening, or to draw on a paper, when we draw on a paper, we have to draw in a 2D view. So considering the first angle of projection, we have VP, HP. Now what is VP and what is HP? So the vertical plane which is always in front of us is the VP, and the horizontal plane, the plane which is perpendicular to the vertical plane, they are mutually perpendicular. So the plane which is perpendicular to the vertical plane is the horizontal plane. And we have to refer the diagrams in top view, front view and side view, any side view. Coming to the views in first quadrant, the first angle of projection in the first quadrant, how to visualize this thing? So to visualize this thing, we can visualize something like this, a 3D view of all the planes together, like this, where the vertical thing is the vertical plane, the horizontal thing is the horizontal plane. And when we open up this diagram, this will look like this, something on a paper. So when we put it on the paper, we have a line which is separating VP and HP and the two planes, that is left profile plane and the right profile plane. So because it is to the left side, from in front of our eyes, this is to the left of our side, so this is left profile plane, and this profile, since it is to the right of us, it is right profile plane on a paper. So on a paper, while drawing first angle of projection, where VP is in the top and the HP is below, what we consider is, if we trace out this thing on a paper, we get a line where this thing represents VP, this thing represents HP. Now to represent the two sides of the two other sides, the left profile planes, we draw a line in middle of that. Why we draw a line in middle of that is because you have the 3D view here. 3D view here, where VP is this side, HP is this side. So you can see this line is the one which divides the two plane, this plane and the downward plane. You can visualize this as a plus. See, plus. So you always write this side VP, this side HP. Now if you have to draw the left profile plane, then this part will be left profile plane. And now if you have to draw right profile plane, you have to draw like this. Your VP will be marked here, HP will be marked here, and LPP, RPP will be marked here, right profile plane. This is how we draw. Now the line which separates the VP and HP, if you want to draw the simplified view of this diagram, you have like this on a paper you draw. So this is your VP, your HP. Since the 2D thing open up like this, so this part become VP, this part become HP, and there is a line which divides it. So on paper you have, there is a line which divides VP and HP. And similarly, if you cross this part, cover this part, you get, there is one more line which divides VP and left profile plane, and the same line if you consider the right profile plane, which divides RPP and VP. So how to draw this part is, you have a line, straight line, and you have a perpendicular line. Now since you have left profile plane, so left profile this side, profile plane this side, and for right profile plane, I have shown you right profile plane should be drawn like this. So this is when you look in the first quadrant. First quadrant means where you have VP in front of you. This is the first quadrant where VP is this side and HP is this side. Similarly, in the second quadrant, you get the same thing The VP is this side, the HP is this side, this way. So in first angle of projection, what we need to consider, how to, if you place something over here, like if you place the cap of the pen in this quadrant, how would you visualize this in a 2D way? That is what is CAD. To visualize this in a 2D plane, first we should know how the object is in with reference to the vertical plane, horizontal plane, and left profile plane and right profile plane. How? Consider this as the first quadrant where I have not shown the LPP and RPP in this block of paper, but I have shown it in this piece of paper. So here you have HP, VP, LPP, RPP. It's like a 3D cube. If you place the cap in a room like this, okay, this is a very big cap, but if you visualize if you are placing this cap in this room, how you will give reference to this in the respect of these planes. That is how the questions comes, and you have to visualize how it is happening. So to make it easy, you have to understand this pen. If I keep it on the floor, like if I keep it on HP, so what you can say, this cap is on HP, and since it is on HP and it is from a distance from our VP, you'll say it is in front of VP, because it is, you can see it is in front of VP, it is lying on HP, and it is front of RPP and LPP. Now when you put it on the paper, your thing is, your cap is on HP, okay, this thing has, if you have folded like this, then VP comes like this. If you unfold this, this will become VP. So it was in front of VP. So the distance which is from HP, is from this line. Yeah, it is on HP and front of VP. So how much front of VP? This distance in front of VP. When you look from top, this line shows here like this. It is in front of VP this way. That means it is in front of VP this way. So that object is here and it is front of VP from this line. That is known as XY line, which divides the VP and HP, and X1 Y1 line, which divides LPP, RPP, VP, HP. So if you consider the case of the cap, you have, it was on HP in front of VP. So from VP in front of VP, this distance, yeah, that if you look from top will be marked like this, distance from VP. Now if the object is in air, but it is in first quadrant, so the object is in air, it is above HP. You can see if you place like this, so this cap is above HP, front of VP, front of LPP. If you make a cube like this and place the cap, it is above HP, front of VP, front of RPP, and front of LPP. Just ignore these sides for the first time. We are only considering the object is above HP. That means it is above HP. So for it to be above HP, you have this distance. This distance above HP, when you see like this. Now since it is above HP, this. So the line goes, if you project it parallelly, if you look through this side, it is above HP. This distance, which is an imaginary line, will show up on VP. So the above HP distance will be showed up on VP when you open up the 3D cube. So this distance is of VP. It was in front of VP. So this distance, it was above HP, so you get it on VP. So whatever the thing you have it on HP will be projected on VP. The distances which are on HP, that means if something is above HP, okay, if something is above HP, so this distance will be projected back to the back of the wall, VP. So any distances which is on HP will be projected on VP, and any distance which is from the VP will be projected on HP, because since it was in front of VP, we were able to project that line from the top here. When I opened the plane, I had VP, HP, okay. Just I opened the plane. I folded it like this. I placed this cap here, and I am assuming like this. Okay. Uh, yeah, the cap is here. Now we can see it is above HP this way and in front of HP from this way. Again, to get it clarified, there's an imaginary line in front of VP. If the object is in air, then the imaginary line which is coming from front of the VP can be seen on HP or can be drawn on HP. To draw in 2D, that is drawn on HP, and since it was above HP means something which is vertical distance. So since it was a cube, that vertical distance was projected on VP. When you open up, you'll get like this. If an object was here, which was above HP, that distance will be projected on VP, above HP distance, and in front of distance will be projected on HP. Whatever is on VP will be projected on HP. Whatever will be on HP distances will be projected on VP. Only the distances. This was the first angle of projection. Now, if you have something considering only the left profile plane, then it was above HP, in front of VP, and in front of LPP. So in front of LPP means a distance which will be marked on LPP. How the distances on LPP are marked is, if I had a point which was 30 millimeter from HP, from VP, and from LPP, if I had a point, consider this a point. Okay, if I had a point which was 30 above, 30 in front, and 30 from LPP, so it would be somewhere here in the air. So how would we draw it on a 2D paper? Since it was above HP, so all the above distances were marked on VP, and all the frontal distances from VP were marked on HP. Similarly, it was from LPP 30. The point lies here somewhere in air. So the distances come out to be something like these three lines. How do we represent it on a paper now? So to represent it on a paper, we have this. Considering the first angle of projection HPVP, the line which divides is x and y, x1, y1. Since it is dividing LPP from VP and HP, this is only this view. If you remove this part, that this part is only represented here like this. Okay, that is LPP. The point was 30 millimeter from VP, HP, and LPP. Since it was 30 in VP, HP, and LPP, the point was here 30 from VP. So 30 from VP, in the sense, from top, if you view this point, okay, if you from the top, if you view this point, this is 30 from VP. So that 30 imaginary line which is somewhere here in the air, when projected downwards to the plane, will be this line. That is 30. That will be this line. Similarly, it was above HP. The point is above HP. From the top, we can only see this cap as a point, this point. So we'll consider as the point object, and from the top, if we see and consider the below view, you get it is above in air, but from the top you can't see it is above, but still we can say it is above in air 30 from HP. Now 30 from HP, that means this distance. So if you project this line backward on VP, you'll get this distance. So this point was 30 from HP, VP, and LPP. So this distance will be 30. Then again, there will be another view on VP, that will be 30. And to draw the LPP, we always draw a 45-degree line here. We project this to this line, then this upward, and a line from this way. So these are the projector lines which direct. So the view on LPP will be this, on HPP will be this, on HP will be this, on VP will be this. This distance is 30, this distance is 30. Now the top view is always referred to as A dash. Since it was the top view viewed from the top views are always on HP and front views are always on VP. Why? Because if you project the image of this cap on a 2D wall backwards, then you get the front view on VP, and from top, if you project it downwards, the top view on HP, and the side view, if you look the circle, then it will be on LPP or RPP anyway. So all the distances on HP are marked on VP and all the distances on VP are marked on HP. It was 30 millimeter in front of VP. So it was 30 millimeter in front of VP. The point was there, 30 millimeter. This distance is marked. Then it was 30 millimeter above the ground. So that imaginary line was marked this way. And it was 30 in LPP. To mark the LPP directions, we always project this line this way, draw 45-degree line. Then we make a parallel line to this point and we join these two lines, this line, and draw the projectors. You should draw the projectors perfectly and the projectors. And you have to mark the distances. So this is the first angle view of our CAD. Now there are 4 conditions. What are the 4 conditions in the first angle view? And to represent the point in HP, VP and RPP, we have some notations. The top view, where the top view is represented on HP and is marked as A. The front views are represented on VP and are marked as A dash. The side views are represented on any of the profile plane, left or right, accordingly to the question, which are not most in use, and it is marked as A double dash. So our question was, a point is 30 millimeter from HP, from VP, from LPP. This part comes in the point section, but to have an understanding of the profile plane, we can consider it. We had drawn VP, HP, and this is LPP. Always remember this 3D diagram. When you open it up, always the top one will be VP, the down one will be HP, and the left and the right profile plane according to your hands and according to the question, you have to draw either of them. This is the first angle of projection. Our point was 30 from all the planes. So the point was 30 from VP. The point was above HP, which will be marked on VP. That is 30 because we have opened up. So it was folded like this, something like this. Since we have opened up, the lines become straight. And for LPP, we draw 45-degree line. We project this line on the 45-degree line. We project it upwards. And from the point, we project so that we get the image of this line. And then image of this point. So this is, we marking the projector lines. Yeah. So the front views are represented by A. The top views are represented by A, the front views are represented by A dash, and the side views are represented by A double dash. Consider that point A, which we have taken, this point, okay? This was the first angle of projection. Now, what are the conditions in the angle of projection? Is you have 4 quadrants, okay? 1, 2, 3, 4. 1, 2, 4 quadrants, okay? This is the 4 quadrants. In the first quadrant, when you imagine an object, so that object can be in 3 conditions. First, if you place the object on HP. So, if you place the object on HP, how would you describe it? You'll describe the object is on HP in front of VP. LPP and RPP you forget for now. So, the object is on HP in front of VP. Or it can be, object is here, the object is above HP in front of VP, or the object can be on VP, so it is described as the object is on VP and above HP. Since it's on VP and above HP, so 3 conditions. First, the object is on VP and on VP, above HP, on HP, in front of VP, or it is in between and it is considered as it is above HP in front of VP. Okay, above HP in front of VP. So all the four quadrants have the same conditions. If you come to the second quadrant, the object is on HP, on VP, above HP, in front of VP. But for the third and the fourth quadrant, if you place the object here, it will be below HP, in front of VP. On HP, on VP, below HP, or it can be in between in the space, that is below HP, in front of VP. Same for the fourth quadrant, it will be not above HP, it will be below HP here. It will be not on HP, it will be below HP. See? So what are the four conditions we are getting here is for the first angle of projection, the object can be on HP, on VP, or it can be on in front of HP and VP. Okay, so you have to write it, the object, you always remember this 2D figure like this, okay? VP, HP. The object can be on HP, that means then it is in front of VP, in front of VP first, then it can be on VP, so it will be above HP, so on VP, above HP, or it can be in the free space here somewhere, so it will be above HP, in front of VP. Third, above HP, in front of VP. Now if you consider the first, second, third and fourth quadrants, you have in the second quadrant, if the object is here, it will be on HP, in front of VP. If it is on VP, so it is on VP, above HP. But for the third and the fourth quadrant, anything which you place will be below HP, in front of VP, on HP, on VP, below HP. So everywhere it will be below HP. That means the quadrants are third and the fourth. Now one more point to note is, in the first quadrant, everything is very clear. It is on VP, on VP, on HP, in front of VP, above HP. Now if you place anything in the second quadrant, it will be on HP, but it will be behind VP, behind this wall, so behind VP. Similarly, for the third quadrant, it will be below HP. Similarly, below HP, it will be on VP, below HP. In the third quadrant, it will be below HP, behind VP. It will be below HP, behind VP. Since this part is the front part of the VP plane, it comes in only in first and fourth quadrant. So anything placed in third quadrant will be below HP and behind VP. So we have conditions. Anything which is in first and the second quadrant can be on HP, above, are always above HP and on VP. But when we mention an object placed in the second quadrant like this, second quadrant, your object is on HP but it is behind VP. Similarly, if you mention an object placed in third quadrant, it will be below HP and it will be behind VP. So there are some common conditions for quadrants. For the first and the second quadrant, things are always on HP, above HP. Okay, on HP, above HP, on VP. Now for the second and third quadrant, for the second and the third quadrant, that refers to these two quadrants, second and the third quadrant, anything is on HP and it is behind VP. When an object is placed in on HP, how would you refer in the second quadrant was it is on HP, behind VP. Similarly, for the third quadrant, it was, if the object is on HP, then it would be behind VP. For third and the fourth quadrant, anything will be on VP and below HP. Anything will be on VP but below HP. We are only considering the objects when it is placed on either of the planes, not in the air or in the space in that quadrant. Now for the first and the fourth quadrant, anything will be on HP but in front of VP, because this was the front wall of the VP and behind that was the second wall of the VP. So everything will be in front of VP. So if you summarize the things, you have four quadrants. Four quadrants. It was like two intersecting planes: first quadrant, second quadrant, third quadrant, and fourth quadrant. So in the first quadrant, this will be vertical plane because it's vertical, and this is the horizontal plane because it's the floor of the room, you can consider, which is always horizontal. So in the first quadrant, anything when you place on the profile planes, like on HP. Similarly, in second plane, on HP. In third and fourth plane, below on HP, but behind VP. Behind VP. Now, if you place an object in fourth quadrant somewhere here, how would you refer this object as? You'll refer this object is on VP, below HP. Now, when a person says an object is on VP and below HP, so below means it is either in third quadrant or in fourth quadrant. So the object will be in third or fourth quadrant. It can be in any of the quadrant. Now, if a person mentions the point lies on HP behind VP, so it can be in second quadrant or third quadrant because the object will be on HP but behind VP. Now if a person mentions it is on VP below HP, so on VP but below HP as third and fourth quadrant. Now if a person says an object is on HP and in front of VP, so on HP in front of VP, first or fourth quadrant. So this is how you recognize the quadrants. Now these two parallel planes, which we consider for the angle of projections, rotate in clockwise direction. They move like this. That means they open up like that. Now open up like that means if this was your first quadrant, VP and HP, they rotate clockwise. This plane comes like this and this plane goes upward. So what happens when you draw in 2D? In what happens to the fourth quadrant? In the fourth quadrant, if this plane moves this way, HP and VP coincides. But HP and VP coincide below this XY line. So, and this thing moves upward. The other side of the plane, the third quadrant HP plane moves upward. If you rotate this clockwise, this comes down and merge with this vertical plane. This one moves up and merge with this vertical plane. So what we get? For the first angle of projection, when you draw on paper, you draw X, Y, X1, Y1 if required. X1, Y1, VP, HP, LPP. For the second quadrant, how would you draw? To draw the second quadrant, you overlap the things like this. By overlapping in the first quadrant, nothing happens. VP remains VP, HP remains HP, and this XY line remains XY line. But in the second quadrant, what happens? The HP which was below goes up. It merged with VP. So you have to write VP and HP in brackets since it is merging, but we can't see it merging. It's kind of imaginary thing. So we have to represent in small brackets, and this is your XY line. For the third quadrant, what happens is the HP moves above and VP will be remaining downwards. So your thing becomes XY, VP, HP. So anything you have to represent in first quadrant, you have to draw it like this. In second quadrant, you have to draw it like this. In third quadrant, like this. And in fourth quadrant, the HP moves below the XY line. Since it rotates clockwise and moves below. We had this four quadrants. The HP moves below. It merged with VP. And it can't be seen in 2D view. So we have to write VP and HP in bracket below the XY line. Below the XY line and above the XY line makes difference because it refers to the angle of projection you are working in. We are always working in first angle of projection in most of the questions. This was the concept of angle of projection. Now to summarize, what have we learned is that there are two perpendicular planes which intersect, with VP the vertical plane and HP the horizontal plane. This moves in clockwise direction, and so this moves upwards. What happens if the clockwise rotation takes place? We get 4 quadrants equals to 4 angle of projection. So how to draw it? The first quadrant, this moves downwards. Always remember this 3D view. VP will be above, HP will be down. This HP will come down and you'll get a flat thing like this. You have to just copy it down. VB, HP. The line which is separating them is known as XY line, whose thickness I have told you in the previous video would be 0.25 millimeter, which is very necessary to remember as it is very important for the questions. Now, only focusing on two profile planes, not the left and the right. For the second quadrant, HP moves upward this way. So what happens? Your VB and HP coincides, but it will be above XY line. Above XY line. Then the third quadrant, your HP moves upward, so you have to draw it like HP VP. And for the fourth quadrant, HP coincides with the VP, rotating clockwise. Your VP and HP will be written below the XY line on any side you wish. Either you can write on the left side or you can write it on the right side. Anyway, for the first quadrant, this is for the first. I was just telling the writing way. Now, for the profile planes, always imagine this 3D view. Okay, you can imagine it like this. If you are drawing on a plane of paper, this was my VP, HP and LPP. If you open this up, what you will get will be a view like this, and it is drawn in this way: VP, HP, LPP, X1, Y1, XY. Okay, for right profile plane, for the first angle of projection, X1, Y1, XY, VP, HP, RPP, since it is on the right side of yours. One thing more to remember is anything whose right profile plane is mentioned, you should always imagine it in a cube, and you should always imagine its profile planes. Or you should always remember this little cube in your mind, so that it is always easy for you to represent any of the quadrants, any of the lines, and any of the planes. Now, other thing which we have learned today is about the representation of points in a first angle of projection. Like we had considered, case A is 30 from all the